So next up we have Amber Case, who is a researcher studying cyborg anthropology and the history of wearable computing. She founded Geo Notes, a developer platform focused on calm technology and location-based information for mobile devices in 2010. The company merged with ESRI, a global mapping company, last year. She has been featured in many publications in the US and around the world and speaks globally on the future of location and the interface. Welcome, Amber Case.
Hello, everyone. Thank you for being here. When I first started coming to this conference, which is still pretty new, it was smaller. I didn't know where the industry was going. I was pretty excited about it. But in a way, all of this was a bit of a figment of our imaginations. I have been waiting for a very long time for a wearable heads-up display that you can actually wear, which is very exciting. And because so much was built for mobile phones, and I just kind of watched things get built for mobile phones, waiting for that heads-up display. It just seemed like an impossible reality that could come one day. So this is very exciting. So I'm here to talk about the future of wearable computing, a bit about the history, a bit about location, a bit about context. So first up, can all of you hold up your phones really quickly? Excellent, excellent. I'm just going to take a picture of you guys with all of your phones here. And if you prank me during the speech, I'm going to get really mad. No, not really. Great. So I'm here to tell you that you're all really just cyborgs. The faster you held up your phones, the more cyborg you are. Some of you are low-tech cyborgs, some of you are higher-tech cyborgs, some of you are more cyborg than others. But in reality, we've all been cyborgs for a very long time, since the earliest use of our tools. Really, the interface that you use your tools with right now is mental, it's ocular most of the time. You have hands, but you don't need to have these things embedded inside of your head to be a cyborg. We've had the cyborg as a word since a 1960 paper on space travel. And the actual definition is an organism to which exogenous components have been added for the purpose of new ambient spaces, adapting to these new ambient spaces. To put it simply, a person in space is really a cyborg. They are not supposed to be in space. Humans aren't supposed to travel to the bottom of the ocean. They aren't supposed to fly in the air. But the external prosthetic devices that we put on ourselves allow us to evolve instantaneously to a new occasion. When we look at the evolution of tools, for the extension of our physical selves, for years and years and years, they don't really change shape or form. They don't change in the way that they're produced very much. A hammer still is an extension of the fist. It's still produced and has the same function and relative size. But a computer is really this extension of the mental self, and over time, it doesn't really look the same. What we're seeing with this is that form doesn't follow function. It's this device that's evaporating. The screen in and of itself is going from these physical buttons to these liquid buttons that could be anywhere on the screen. And when things go from solid to liquid, the next step is air. So when I was studying this, I was really interested in the next generation of the interface. If we have solid buttons and liquid buttons, the next buttons must be something in the middle of the air that you must walk into. But when form doesn't follow function, we see that these devices, as Mark Weiser of Park Research said, are retreating in size while increasing in power. They're becoming larger on the inside than they are on the outside. And their form doesn't really follow what their function is. If you look at the evolution, we have Steve Mann here, so I'm not going to talk as much as I usually do about him because he's here to actually represent himself tomorrow on stage. But what he really wanted to do, and there's a number of things he wanted to do, is instead of being constrained to a computer, if you were walking around in a park and you had something interesting to actually write down, you'd be able to write it down right there. Suddenly, reality was yours, and you'd be freed up to do these things. And this was one of the promises of wearable computing, that you'd be able to be you instead of in front of a computer all the time. This is a portrait of himself with a wearable computer. This is what he called diminished reality, where he could actually block out certain pieces of reality and read his text messages on top of it through a wearable heads-up display. He could register people in the system and actually say, here's the history with this cashier, and here's what I bought last time, or somebody's birthday, or something like that. This whole computer-mediated reality type piece. And when I kept going into this and researching it, I came upon the idea of calm technology from Mark Weiser at Park Research. The idea of calm technology is that the interface gets out of the way, and it's this kind of relaxing experience. A lot of technology hasn't really been built for humans for a long time. It's been something that's really gotten in the way. There's been too many pieces of puzzle pieces to put together, all these different buttons that you have to press to just get to the piece that you want. So calm technology, conversely, is where your actions can become a button. There's invisible interfaces where if you do something, something else is triggered. And in doing so, you can have some sort of ambient notification, so where a process occurs in the background and data is just pushed to you. So let's give some examples. Your location, your time of day, maybe your weight, maybe your average speed over time, prior actions, whatever you want to stitch into this interface. And I think of this not as necessarily augmented reality in the visual sense, but non-visual augmented reality. There's a lot of stuff that you don't need to see that starts getting triggered. Now, even as recently as 2006, we weren't able to do anything like this. First off, GPS wasn't readily available on phones. It wasn't cheap. It really drained the battery. The marketplace and app stores weren't actually there, so you couldn't download anything onto your phone. Very easily you could, but it was a real pain in the neck. And it wasn't mature enough as a development platform because nobody wanted to do, I mean, people did, but it was really a pain in the neck to do J2ME or as a developer actually get anything into a store. You would require a lot of money. Even articles like this, functional location-based reminder applications, which is leave yourself a reminder at the store to remember the milk. When you get to the store, your cell phone will tell you, get some milk, was widely criticized when it got published in blogs and newspapers at the time. We've had a lot of changes since then. One of the things that these can do is really make what's formerly invisible visible. So my co-founder, Aaron, made this GPS map of his entire life in Portland, Oregon over the course of a few years. He took a GPS device in his pocket at 5-second intervals that would record his location every day persistently. It's been about 5 years. This is a map of 3 years. It's color-coded by speed. So you can actually see the red in the middle is him going on a highway. The black towards the left-hand side is him driving around really slow, trying to look for parking in downtown Portland. But you can actually see this entire map that's been created of who he is. So we started thinking, what can you do once you have all of this data? If you have somebody's location at 5-second intervals, what can you start to do? So finally, the invisible interface showed up, the invisible button that when somebody goes somewhere, you can have some sort of action happen. It's this trigger for reality. So we started building a bunch of different things. We built this thing called Geo Notes, where you could basically just go into a map and leave a message for somebody, and then when they went into that place, they'd get it again. So I opened up my own map and I said, leave me a location-based message anywhere on this map. And we had a little Geiger counter type thing that would say whether I'd be likely or not to get a specific message. So I started getting all these messages all over the place. I'd be walking down the street and I'd get a message that said, hey, there's a blackberry bush over to your right. You should check it out. So I'd go and eat a bunch of blackberries. Like it wasn't like there's a Starbucks to your right. There's blackberry bushes. Or I'd walk over a bridge and people started leaving me bridge trivia. Like 20,000 people go over this bridge every day. Did you know it was built in this time period? Or hey, you just passed my house. Drop in and say hi anytime. And it was this fascinating new way to actually experience reality. And I wasn't using a computer the entire time. I was just getting the information when it was necessary. And most of the time, it was very useful and interesting. It was a new way to communicate. And so the idea of ambient notifications, this is an early prototype where it says, I'm on the Burnside Bridge. So then we started to say, what if you could use this to control real world objects? So we hooked this up to the house, and when we got home, the lights would automatically turn on. And then when we left, the GPS circle that we drew around the house on a map, then the lights would automatically turn off. And so we thought that this is the opposite of what was there before, the idea of top-down location. This is really bottom-up location, where the location is actually empowering you to do certain things, to get information that you're interested in, actually change things around your environment. So we believe that really location should empower people, and that at some point your phone could become this remote control for reality. Now, we thought this was great, but there were a lot of different problems that happened. One of the problems was battery drain. This was the biggest problem. All of you have used location-based apps, have had significant battery drain, and haven't had great battery life. So we decided if we made an algorithm that reduced battery drain while providing these location-based notifications, we could actually have a platform that people could build and bring all of this to life. We felt like this was holding back the industry, and we needed to solve this problem. The second thing we needed to do was actually solve for an easy way for people to actually add these notifications in. So we started working on that. Another issue is, of course, privacy. Right now, what's not solved is who owns what data and how do you allow an app access to that data. Right now, it's okay or no. This app wants to use your location, yes or no. It should be, this app wants to use your location when you're at the following places. Any other location information won't be stored on our service and will be deleted. We will give you your, you will get this in return very explicitly. It's really a negotiation between a user and the app. Now, that isn't really being done yet, so that's a whole new frontier that we need to work on solving. And then also ads. I used to have a drinking game around anybody who said, let's use location to find the nearest Starbucks or to give you a location-based ad for Starbucks coffee. The problem is, if you're a Starbucks customer, you'll probably pay for like full price for a coffee, and you don't need to have a location-based app to find the nearest Starbucks because they're everywhere and they're really easy to find. And for me, this was a very boring use of location, a very boring use of augmented reality. I thought was more interesting, there are better ways to do ads. We have a customer that has a racing game, and then it geocodes all these convenience stores and actually sends you a message if you're near them, and you can scan a can and actually like get power-ups in the game. So it actually gets people to go to the store, and sales of the energy drink have gone up since this has been implemented. But there's all sorts of more interesting things you can do with this software that doesn't necessarily have to do with advertising. One of the things that we wanted to do was start to bring all the static content to life. On the web, you have all this information that's stuck there. You have to actually go out to the web, sit there in front of your computer, and determine what you're going to do with it, right? So let's say you have all of these Wikipedia articles, but a lot of them have geolocation attached to them. Wouldn't it be nice if you could actually get these Wikipedia articles when you're walking around? So one of the things that we did is we took all the Wikipedia articles with geolocation on them and we put them into the system. You actually walk around and learn about your world. A lot of times you might walk past a building, you have no idea what that building is about. One of the examples is there's the world's smallest park in Portland, Oregon. And I got a notification one day about this tiny park. I would have never been able to find this park. I mean, it's literally that there's a gardener that's hired to maintain this park from the Parks and Services Department. But I got this notification, and I went and I found this park. And it was just something that, it's a small thing, but I learned a lot more about my reality because of it. Also, we hooked in bus notifications. So you'd actually, if you were waiting at a bus stop for a little while, it would actually give you a message about when the next buses would show up. We open it up to developers, and some of the things that they made, this one's called Don't Eat That. It takes all the restaurant inspection scores of restaurants in the city and actually tells you what not to eat if there's a bad inspection score on the restaurant. And then we wanted to make a real-life Pac-Man game, so we made this game called Map Attack, where the city streets actually had these little notifications and geofences, and you could run around and actually capture them, capture the flag style. And we debuted this at Stanford University during WEAR Camp, and what we noticed was all these adults were running around for like 3 or 4 miles not noticing it because they had a goal in reality to go towards. We all had lots of exercise. But there was this guy who actually was out for a really long time, and when he came back, I said, what happened? He said, well, when you made the map, you put a 50-pointer in a construction zone, and I couldn't get to it. And I said, well, how did you get it? Because it looks like you got on the map. He said, well, I just went up to construction work and I said, can you hold my phone and like walk over there so I can get the 50 points? And he said, okay, sure. So he does. And he's like, I got 50 points. What the heck are you doing? And the guy said, well, we're playing this game, blah, blah, blah. And the construction worker said, in the 15 years I've worked here, no one's come up to me and actually talked to me. I see everybody on their phones. There's no incentive for anybody to run around or interact with each other. And you've really made my day. So they had this giant conversation and he came back. Very elated. So location really isn't enough. There's this whole kind of quantified self movement going on, which I really like to call Big Mother. It's kind of a disembodied mother telling you, you shouldn't eat that, you should do this better, your weight's going up, it's because you didn't sleep that well, and you should get to bed earlier. And it's done all through this data. My friend John Lubkowski said, of all of the newest technologies that I have, a lot of them are for friends or for dating. I have lots of friends, I'm married. The thing that I don't understand is myself. When you take something outside of yourself, you make what is formerly invisible visible. You can start to understand trends that you might not be able to understand as just a person working in real time. And so, all of these data sets can be generated by sensors, right? So like your sleep or your happiness, ambient noise, weather around you, the time of day, maybe your productivity, your stress level. But the problem is that you really need a correlation of all these multiple data sets to have real meaning. And the problem with this is that we have this kind of Tower of Babel going on where everything has a different protocol, everything speaks a different language, and it's really hard to stitch them all together. Now we can with a lot of work, but this makes it very interesting. So we have location as one piece, which we can get in, but wouldn't it be nice if you were going to be warned of the onset of a heart attack based on your history and all of these different variables? Or that you were going to a dangerous intersection because based on the last year of information, this intersection was much more dangerous than the others. And you could actually make a route around a city that was the safest. Or if you're asthmatic, to not have an asthma attack. So really, we need more low-friction data collection and frictionless correlation. And then, to conclude, I really think and agree with Mark Weiser that the best technology is really invisible, that it just gets out of the way and helps you live your life. And you interact with it when you need to, and it's there when you need it and not there when you don't. And there are different ways to make these kind of calm interfaces that aren't in your face. I would encourage everybody to make the minimum user interface to get something done for a person. So like this, instead of something big and clunky, these guys are actually playing a game of map attack and they got 50 points. You can't even tell that they're in the middle of an augmented reality world of points in the city streets. They've also gotten lots of exercise, so they're no longer in front of computers. So thank you very much.